All right, the final part of your SLO deals with multiply, divide, and simplify expressions. So these are just bigger forms of the distributive property. So for example, we're going to have something along these lines. And it's just going to test your ability to multiply terms together. So like when we did, real quickly, when we did FOIL, okay, and this was maybe 2x, and this is maybe 3x, and we just did FOIL, right? 3x times 2x is a 6x squared because you're adding the exponents, right? X and x, okay? So 1 plus 1 gave me that 2. And when I did my outside, right, I get negative 8x, positive 6x, and negative 8 for my last. Okay, but then these, notice the difference here, we actually combined because there were like terms. The exponents were the exact same, so I just combined the coefficient in front to make that negative 2x. So the key here is understanding the same idea, just on a larger scale. When you multiply, you have to add the exponents. So like here, I'm multiplying those. So that's how I got 2. Right, so I add the exponents. But when you add or subtract, them, okay, you just combine the coefficients. Okay. Now, to do this one, you say, well, this second one here is a trinomial. So how do I actually do that? Because I can't FOIL it. Well, you take and distribute the x minus y to all 3 terms, because technically I could have done that over here with this as well. We just FOIL it because foiling is easier, but I could take the 2x plus 2 to both of those. So I'm going to color code this real quick. So I'm going to take the 3x and the negative 4. I'm going to put those in the front, and I'm going to take the 2x plus 2 to both of them. That's still going to give me the same answer. Okay, there's my 6x squared and my 6x. Here's my negative 8x, and here's my negative 8, which then again, that's negative 2x, and you're back to the beginning. So you're going to use that same process with this one. You're going to take the x minus y to all of the terms after it. So you have the x squared, you have the positive 3xy. Okay, notice I put the sign that's in front with it, so I know how to combine the like terms later. So each one of those 3 terms, those are going to go in the front, and your x minus y's go there. And then you're just off and distributing. Again, when we multiply, we add the exponents. So there's a 1 there, so 2 plus 1 is 3. All right, x squared times a negative y, first of all, is negative because a positive times a negative is negative. They're not like, they don't have common basis, so you're not adding those exponents. You just write it down. Now here, when I do this one, the x's will be x squared, but everything else does not change. Now here, the y's will change to be y squared. And then here, as that goes through, I have x y squared, and here y cubed, but negative because it's a positive times a negative. And if you look closely through this, you actually have a 2 sets of like terms. Okay, these are like because they have the same expression x y squared, so they have the same variable and the same exponent, which makes them like terms. Now, we can go ahead and do that. So all I have here is a negative 1 plus 3, which is negative 1 plus 3 is 2. And when I add those, the expression stays the same, just like it did when I made it negative 2x. All right? You're just combining. Now that's a positive, so you're going to have to put that plus in there. So that would make sense, x cubed plus 2x squared y squared. and then negative 3 plus 1, okay, is going to be negative 2. Okay, and then you have your negative y cubed. So that is how you go through that. Now you can't go any further because none of these, this would be your final answers, none of these are like terms. Okay, yes, these here are both x, y, but the exponent of 2 is on the wrong variable, which makes them not like terms. 37 is the same idea. It's actually a little bit easier. It's just going to be something like this. And you just distribute. Again, adding the exponents when you multiply them, which is what we're doing when we're distributing. So 5 times 2 is 10. X times x, x squared, and then you got your y. Minus 15, x, y times y is y squared. Pick that one through. So positive 6y squared. Okay. You can write y squared, x squared, or you can write x squared, y squared. That's the commutative property. Either order is fine. And 12, y squared. And none of those are like terms. So you would be done. 38 and 39, you will be dividing. These are just like simplifying expressions where you have some common bases. So here we have something like this. So if I have this, I just want to focus on one part, and then it'll make sense as far as how easy this is. All right. A to the 8th is really a times itself 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 8 times the 4th is 8 times itself 4 times. So if 4 of those cancel, as they can because they're products, you can, as part of fractions, is crossing out those, and you're left with 4 a's on the top. So that would just be with a to the 4 on the top. Now, if I focus on this next one, b to the 6 over b to 10, same idea. You would have 6 of these, 4, 5, 6, 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're left with 4. Where? On the bottom. Now the shortcut is just to subtract the exponents. So when I go back to my color of black here, so a to the 8th over a to the 4th is the same thing as a to the a minus 4. A to the 4th, which we got before. And the other one, if you have b to the 6th over b to the 10th, you would have b to the 6 minus 10, which is b to the negative 4. Now what the negative means is that, do one more, it means that you can put it on the bottom and make it positive. So that's a property of negative exponents, that anything to a negative exponent is equivalent to that exponent on the bottom. All right. So if we continue that pattern here, I'm just going to left with c squared, 6 minus 4, which is positive 2, so therefore on the top. And then 9 goes into 18 twice. So that's just simplifying. You can put the 1 there if you want. You have to put the 2 there. But 1 is not really necessary, as 1 times something does not change it. So that would be your final answer. Last but not least, you have a division of polynomials in which you have to factor to create a product. Now, I'm going to give it to you like this horizontally, but I want you to take the time to rewrite it as a fraction. Now, what I want to prove to you here is that you have to create a product in order to cancel out, like I was doing up here, okay, you had to have products in order to cancel these. Okay, well, if you look at this expression, I don't have a product, right? I have subtraction signs and a plus sign on the bottom. Now, that's why we learn how to factor, is because it creates products. Real quick, just want to show you why. If I have like 2 plus 3 over 4 plus 3, okay, so here's why you need a product. All right, we know that this is equivalent to 5 over 7. But if I incorrectly use the fact that I can cross out these 3's and say it's 2/4, well, obviously 2/4 and 5/7 do not match up. Those are 1/2 and 5/7 are not the same. But if I change that to a product, okay, if I change that to a product, times 3, times 3, okay, and I go the old way, 6 over 12, that is 1/2, which is the same as if I were to just cross it out and get 2/4. Right? These are equivalent. So it's all about getting that product. Well, I can do that by factoring plus minus and A, and then you say, okay, well, I need to get this smiley face to be this. Now, on your SLO, I'm going to, you can kind of cheat. Since the bottom is a plus 2, one of the factors has got to be a plus 2 because that's what's going to cancel out because I'm creating the product right there by factoring, which I can cross out that entire a plus 2 as that is one term being multiplied. Now, so I'm going to use 2 there. You know that this one would have to be 10 since your last term is 20. And that smiley face does work out to be negative 8a, 2a, and negative 10a. It would be negative 8a. Nonetheless, the a plus 2 will cancel, and you're left with just a minus 10 over 1. Now, when that crosses out, you're left with a 1 on the bottom. Okay, so anything divided by 1 is just a minus 10. Okay, now again, why is that 1? That's just real quickly, right? That's why we divide these single step equations by the coefficient. 4 divided by 4 is a 1x. So 1x or x equals 1 is the same idea that I'm doing here. Okay, a plus 2 over a plus 2 is 1, right? So there's a 1 there too. But 1 times a minus 10 is just a minus 10. Okay, in short, you're just left with a minus 10.